Okay, so this is the last of the video lectures that you'll be watching for the week of the 21st through the, 21st, 22nd, 23rd. So this is to replace the lecture on Thursday, the 23rd. It'll be on the urinary system. We're back in the lab again. The guys from maintenance are outside. The radios will come on in just a minute, so you'll hear that as well. Again, all of these lecture series are in little 15-minute segments. So there will probably be 4 to 5 of these as we go. We will do a little bit of work on the board, not quite yet, but as we get probably to the middle of the lecture. So you might want to have a couple of different colored pens, reds, blacks, orange/yellow would be good. And then just kind of a defining color that you can visibly see as you start to work your way through the urinary system. Once I introduce all the parts and pieces, then we'll go back and I'll show you the flow and the pathway for that, okay? So, urinary system, if you get nothing else out of this lecture, please, 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 for the love of God, make sure that you know the urinary system rids the body of waste products. Yes, but let's be more specific. The biggest component that the urinary system is trying to void out is called nitrogen. Nitrogen is a byproduct of all the protein in your body. Every single amino acid, and I'll show you this when we get to the board, every single unit of protein is made up by amino acids. Every amino acid has some nitrogen associated with it. It's called nitrogenous waste. It's the only element in the body that cannot be voided out as a gaseous product. And so it has to be eliminated as a solid waste product or a solute in solution. So urine is actually a water-based substance to allow for the ridding of a solute in that solution, okay? So again, if you get nothing out of this, the number one waste product of the urinary system and the number one function of the urinary system is to remove nitrogenous waste from the body, okay? We'll also talk about blood volumes and pressures and compositions. We'll talk about the shared pathways for the reproductive system. Again, we'll talk about this when we get to chapter 27. Functions of the urinary system. So here are the expected outcomes. This is what I think that you should be able to answer by the time we get done with this lecture. Again, major nitrogenous wastes and the sources of them being rid out through creating that urine product for excretion, okay? Please make sure you know the term excretion. It means the removal of waste products. This is the, we're gonna do just a little bit of anatomy. I'm not gonna spend much time in this at all because you will be doing this in the lab with Tom. You should have probably done it by the time you watch this video. I don't know, maybe not. But you will be walking through the component pieces and anatomical structures of the urinary system in the lab this week, okay? Here we go, 6 organs, 2 kidneys, 1 here, 1 there. So we're looking at the anterior view right now, and you will very visibly see that the one on the right side is just lower than the one on the left side. 2 ureters connecting, and because this one is just a little bit low, it's probably just a little bit shorter on the right side than the left side, and then 1 urethra leading away from that urinary bladder, okay? So kidney, kidney, ureter, ureter, into the bladder, and then into the urethra for the exit. Again, just because we happen to be looking at it right now, look, that kidney on the right-hand side versus the kidney on the left-hand side. The liver is sitting right here, and the liver, we have to make some room for the liver, and so the liver actually displaces that right kidney just a little bit, okay? So the kidney on the right-hand side is just slightly lower than the one on the left-hand side because the liver is taking up that space. The other thing that we'll see, you see all of the arteries and veins running right down through the middle of the body, and the sizable amount of vasculature that's exiting off. Well, they can't all exit in one place, right? They have to have space to be able to move through their own, because we don't want to impede the blood flow that's there. And so what we find is the one on the left-hand side is just slightly higher because the aorta is on the left-hand side of that vena cava. And so the exit for that renal artery coming off of the aorta is important, the placement and the height of the exit. And so that left kidney is just slightly higher than the one on the right side because of the exiting of the aorta and the crossing over of this renal vein coming back out of the left kidney. Please make sure that you know the kidneys are what we call retroperitoneal. We'll talk about it in just a minute. So they're not actually sitting inside the abdominal cavity. They're sitting behind the fascia that cordons off the abdominal cavity. Therefore, when we look at the kidneys and we reference them, we always reference them from the posterior aspect. Okay? And we'll talk more about that as we go. Functions of the kidney. Absolutely have to know this. And again, on the list, the removal of waste product in the nitrogenous waste is not at the top of that list where it should be. So, number one, first and foremost, absolutely, right off the top. Functions of the kidney, removal of nitrogenous waste from the blood. Okay, now it says, here's the function of the kidney, and I'm going to show you this on the board. Filtration of blood plasma. Absolutely. Now, we talked about the fact that the two largest areas in the body for blood filtration, number one, the liver, number two, the spleen. Well, here's the third location. There is a large amount of blood filtration that goes on at the kidney, but I just scared you, didn't I? Good. We are filtering out nitrogenous waste and the blood plasma. This does not include all of the whole blood. It is simply a filtration of the blood plasma. Okay, so remember, 45% of our whole blood component, 45% of red blood cells, 1% is that white blood cell or that buffy coat, and 55% approximately of that whole solution is plasma. It's the water-based component. It's 90% water in its makeup, and it is driving or carrying or through the process of osmosis, transporting a number of solutes that tend to be inorganic in their makeup. Okay? So, number one function of kidneys to remove nitrogenous waste by filtering the blood plasma. Therefore, we can excrete toxic wastes. Number two, regulate blood volume, pressure, and osmolarity. Well, how do we do that? What did we say the number one determining factor was for regulating blood volume? It's the amount of water that's available in that blood. Remember, the more blood, the more volume. The more volume, the more pressurization. The osmolarity is the amount of solute that can be carried in that solution. So we're also talking about the viscosity or the thickness of it. Okay? Kidneys also. Now, when we talk about the functions of the kidneys, we are directly relating the filtration of that blood plasma. Remember, 90% water. That's a huge amount of our water supply that's being filtered through that blood. Okay, so we're going to clean the blood plasma, and we're going to make sure it gets reinfused with a lot of water by recycling it back up through the kidney. We'll talk about that as we go. Regulation of electrolytes and acid-base balance. We'll talk about it some here today, and then when I come back, we'll do chapter 25 in the lecture hall, and that one is key for those of you going to Nursing 1, because the first couple of weeks of Nursing 1 will deal directly with the acid-base balance and the electrolyte content in your body. Okay, secretion of erythropoietin. Now, go back to the endocrine system, and we also talked about it when we talked about blood. Erythropoietin is a hormone that is released from the kidney that helps to stimulate red blood cell production in the bone marrow. So here we go. Erythropoietin, number one, produced by the kidney. Number two, its target tissue, red bone marrow. Number three, its function to stimulate red bone marrow production. And number four, if you, the pathology for it, if you are unable to create or unable to release erythropoietin, you'll be unable to make new red blood cells, and you end up with a condition called aplastic anemia. Kidneys will also regulate calcium levels. Now, this feeds right back into this electrolyte and acid-base balance, so we'll talk about that. Clears hormones from the blood, detoxifies what we call free radicals, those oxidative components in your body from environmentals that would cause damage to the cells. And it can synthesize glucose from amino acids if needed. But that's kind of a secondary function, okay? Position of the kidney, again, it sits retroperitoneal, so it's behind or sitting posterior to what we call the peritoneum. And the peritoneum is that big sheet of connective tissue that compartmentalizes the abdominal cavity. And so what you find is sitting in the posterior aspect, so here is our abdominal cavity, there is that peritoneum, and then they sit kind of retroperitoneal. So again, when we reference the kidney, we're always going to reference it from the posterior side. Real quickly with the virtual dissection, as we take all of that material down, what you'll find is there's the kidney, aorta, inferior vena cava. You'll see that the renal artery running underneath with the renal vein running on the superior aspect. Again, left kidney, right kidney, slightly lower in its placement to allow for the vasculature to move across that area. Okay, we'll take apart and look at the parts and pieces here in just 1 minute. Let's talk about nitrogenous waste. Again, nitrogen. Every single protein structure in your body is made from what we call an amino acid. Amino acids, and what you see with our amino, and break that down, amine is NH2. Now, right here, this is ammonia, it's NH3. Amine is NH2. The acid component for our amino acid is COOH. And so you have NH2 combined with COOH to make our amino acid. Well, if we're breaking this down in our metabolic waste component, we're going to take protein and we're going to break it into its amino acid component, amine NH2, acid COOH. We're going to remove out that, so every single amino acid in your body has that nitrogenous waste that can only be filtered out through, or as a solute through the urinary system. That NH2 gets converted to a product called ammonia in the liver. So after, and we'll go through this as we go through the lecture, that plasma is separated off from the whole blood components. The whole blood components stay in the blood vesseling system. The plasma is pulled into what is called the nephron, or the functional unit of the kidney. We'll come back to it in a minute. That nitrogenous waste is separated off and then reabsorbed back into the system to be shuttled over to the liver to be converted to ammonia, and then ammonia converted to a product called urea. Ooh, I've heard of that before. And so there you see your NH2, that urea component that eventually will produce uric acid. Okay? Urea and the uric acid eventually are the starting components for urine. Okay? Really important for you to know, those of you going to the nursing department, what we call the BUN, or the blood urea nitrogen levels. That just tells me how much nitrogen is in your blood that's being removed as waste product. There are the numbers for the normal concentration. But I want to focus on these guys. Azotemia is an elevated blood urea nitrogen level. It means that the kidney probably is not functioning to pull off enough nitrogenous waste, and is a big indicator that maybe there's damage to that kidney and that nephron unit. The other one is called uremia, caused by too much nitrogenous waste because your patient can no longer keep enough water in the system, either due to vomiting, diarrhea, it may be a cardiac arrhythmia. These are the individuals that we will immediately put onto hemodialysis. Ooh, I've heard of that before, right? Okay, so we're going to take the blood out of their body, run it through a separator, in which the separator will then take the whole blood components, or I'm sorry, the formed elements, red blood cells and white blood cells, and put them back into their body. The yellow fluid that you see coming off of there, called plasma then will be run through a filtration device to take out any of the excess nitrogenous waste that's there and recycle the water-based component back into their body, okay? Just a couple of clinical terms that we need to, or a little bit of vocabulary that we need to get through. Number one, excretion, separation of waste from the body and then eliminating them. There are four, you have to know this is a test question. There are four body systems that will carry out excretion. We already know about the digestive and the urinary, okay? Because we do those on a regular basis, daily, to get rid of our waste. But here's the other two that you may not necessarily think of as excretion or filtration devices that separate waste product and remove them for us. Number one, respiratory system. Absolutely, CO2. What? Yeah, huge amounts of CO2 in water. Number two, the integumentary system. Sweat, okay? Water, inorganic salts, lactic acid, urea, a little bit, not much, but a little bit comes out in that sweat. Make sure you know the four body systems that are carrying out excretion, because there will be a test question on them on the exam. Know the basic components that are being excreted out as well. So when we look at the digestive system, we know that bile pigments and cholesterol, lipids, are being transported out through that. Remember we talked about bile pigments and the coloring of your excreted waste, and there's a reason that that is brown in color. Urinary system, a lot of our metabolic waste, so it's a fail-safe dumping system. It's an excess valving system for a lot of the minerals that may be increased above the normal limitations, things like potassium and sodium.